Cool. Well, before we really get started, the exercises that we're going to do are most fun if you actually participate, of course, but they will also be most fun if you do them on with using pen and paper. So just so that we don't disturb the exercise while we're actually doing the talk, if you don't have pen and paper handy, grab pen and paper now, so that you have them ready when the exercise comes, because the time that we do on each exercise is relatively limited. So don't lose time then. I'm seeing Jousef is outside of the screen, so I'm assuming he is grabbing pen and paper. You can also do it, of course, if you have fantastic. If you open a Word document, of course, you can type in a Word document, but then you have to switch between Zoom and the Word document. This is all extra fluff that your memory doesn't need. We will get to what your memory needs later. So just giving everyone a chance to grab a piece of paper before we start. Hello, everyone. My name is Felienne. I'm a professor in Amsterdam in the Netherlands, where I research how to teach programming. So teaching programming and learning programming are sort of my core area of expertise. And today I want to do a few exercises with you on how to read code. But before we go to the actual exercises, I also want to talk a little bit about my background, but also I want to talk about how we as a field of programming, how we typically engage with code, because very often it isn't engaging with code by reading code. That's sort of an atypical thing to do. So I want to take you through that as well. I'm on Twitter. I don't know, are people still on Twitter? I'm still on Twitter. So my Twitter handle is just my first name. So if you do want to check me out on Twitter, then this is where you can do that. So taking you back into my history into reading code and teaching programming, very often if people hear that I'm a professor of computer science education, they think that I have a background in education or in psychology or stuff like that. But I actually have a background in programming. I have a PhD in software engineering, and only like later in life, I got an interest in education. This was specifically in 2013 when I started to teach children programming. So this was a group of 10, 11, 12-year-olds, and they wanted to learn programming. And I thought, okay, this will be easy because they're little children and I know everything about programming. So this will just be super easy to teach children programming because I know programming, even though I didn't know that much about teaching, but I thought it would be easy. And what happened subconsciously, of course, not explicitly, is that I started to think back on how I learned programming when I was a kid. So this is me, tiny Felienne, behind my dad's really big computer, learning to program. And this was in end of the 80s, early 90s, when I was learning to program. And I didn't have a programming teacher, right? There wasn't a programming lesson, because where I was, no one knew programming. There was no adult in my vicinity that knew programming. So I didn't go to a programming club. I didn't have programming lessons in school. I didn't have an idea of what a programming lesson would look like. I didn't have this. So I didn't have programming lessons, but I had a book. And this book, it wasn't a book that would really teach you something. Maybe some of you also share this experience, people my age. If you would open this book, then it would just be printed out source code. So in a sense, it was very much code reading, right? But it wasn't guided in any way. You would just manually type everything into the computer and then it wouldn't work. You would get many compile errors and you would try again, and then ultimately it would work. And this is an experience that many people sort of in our field share, specifically people like that are now in their 40s. They don't really have a memory of a programming lesson because maybe they only took programming courses while they were in university. So as a field, we just don't know what education looks like because we never took education. And then there's much survivor bias in the type of people that actually enjoyed reading such a weird book and figuring out what it does. And you still see that survivor bias today, right? Maybe you're like, why does it matter what children think about programming? Well, what we think if we teach to kids is very much also what we think when we teach maybe when we onboard a junior in a developer's team. because we very much think that if you just drop people into a code base, whether this is a 10-year-old or whether this is an undergrad in a new project in your job, just let them explore, right? You just give them the code, everything's there, it runs, there's maybe tests, there's maybe documentation. Just give them the code and everything will be fine. Something we never, ever talk about is remembering syntax, right? The more I started teaching, the more I realized that these kids I was teaching really needed some basic understanding of exactly what the syntax was. Why do the brackets go there? Why does the space go there, right? But this is not what our culture values, right? Because what do we value? Memorizing syntax? No, it's not about syntax, right? I have said this many times to junior developers that I work with, to children, to students. Like, it's not about the syntax. Syntax doesn't matter, right? Because you can just Google. If you don't know syntax, just look up the syntax. It doesn't matter because you can Google syntax, but not logic. What is a developer? A developer is just a person with better than average Googling skills. So as a field, we do not believe that knowledge is important. You don't have to know anything because you can just look stuff up on the internet. And this is very much the type of teaching I was doing for children, for students, but also onboarding people into projects I was working on. I just thought it doesn't matter. It doesn't matter if they don't understand the syntax, as long as they understand the big picture, right? And you so clearly also see this in materials that we write for children or for other novices. You would see stuff in coding books like this. It's in Dutch, but there's a translation for non-Dutch people. So this says, never be afraid to mess around and experiment, right? I give you the code. Do not sit down and read it. Reading is boring. Do not read it. Do not sit down and like contemplate this in peace. No. Dive right in, mess around, experiment. And this is very much core to what we believe about how you should learn a new code base. So this was my thinking, right? When I was teaching these kids early on, I thought, just push them into the code base. Everything will be fine. Unsurprisingly, for people that actually know teaching, it was not fine. I saw the kids struggling with the same things all the time. Every week I was explaining them the syntax of a for loop. Every week I was telling them, no, in Python, you have to put the colon at the end of the line. It didn't go in. So I was like, this is weird. I'm allegedly a good teacher. People tell me I'm a good teacher, but I'm not teaching well. And then we have to go back to like the beginning of this talk where I said I didn't know anything about teaching. I knew a lot about programming, but basically nothing about teaching. Because the other interesting thing is if you go to a computer science program, if you have a traditional background like me with a bachelor and a master's degree in computer science, you never learn anything about learning. There's not one course about learning. We say, oh, programmers, they learn new stuff all the time. If you're later a professional programmer, you will learn many new languages. Learning things is important, but we don't tell actually people how they learn anything new. So I got sort of obsessed. I was like, but how do people learn? I want to know. And what I figured out, specifically, I learned a lot from how people learn reading, like reading natural language, because there's such a wealth of research into how children learn their first and also their second natural language. So I read this and I thought, wow, we know nothing about how to teach reading code in comparison to teaching language. We really don't know anything. But what I also learned is that we never explicitly teach learning, right? So in this programming club, I would be like this. A kid would come to me and say, hey, I made this program 2 weeks ago, but I don't really remember. What does this do? And I would tell them, what do you think it does, right? I would be very reluctant to give them the answer because I wanted them to mess around and experiment. And this is also very true for junior developers. Very often junior developers, when they're onboarded, they will also ask questions like, well, I look at this class and I don't really understand what it's doing, right? And there's really this culture where we don't want to give the answer. We don't want to say, hey, you don't know what this class is doing? This is what it's doing. We really value people figuring it out for themselves. So you might want to give someone a hint, like, oh, maybe you look there, but just telling people what they want to know sort of ruins the fun of exploring and messing around, right? And I would do this specifically to kids, and they would be like, I don't know what it does. If I knew, I would not be asking you. Just tell me. And if you compare this to what we do in like traditional education, right? If we teach people languages in school and they don't know a word, we would just tell them. You wouldn't say, oh, you don't know the word apple? Tough luck. You would break the problem down in small steps, like, do you know the first letter? Do you know the last letter? What parts do you already know? And this is not just for school teaching, right? Very often people say, yeah, but programming is not a school subject. But also subjects that are traditionally taught out of school, like music or sports. We also don't say to someone in a guitar lesson, hey, buddy, here's a guitar. Just like make some music, just figure it out. Right? There's lots and lots of deliberate practice in music and lots of deliberate practice in sports. Do we have deliberate practice in programming? Not really. So stepping away from teaching children towards teaching professionals, even if you're a professional, I figured out by looking at research that people don't practice code reading if they're professionals either. Here's a paper from 2017 that says that professional programmers spend over half of their time, almost 60% of their time, reading code. That's so much time that you spend day to day, every day, reading code. But we still have the idea that if you want to learn a new language, you should write it, right? Oh, I want to learn TypeScript. Oh yeah, why don't you build a little app in TypeScript? Building is always the path towards learning. And this, of course, also has something to do with this never be afraid to mess around and experiment vibe. No one would say, oh, if you want to learn TypeScript, go to GitHub and take some TypeScript programs, print them out on a sheet of paper, sit down and read them carefully. That's just so not the way that we learn. And people also wouldn't say, oh, you want to learn TypeScript? Here's the 25 most important syntax concepts, memorize them so you're familiar with them. Those forms, they're just not there in the spectrum of things that we consider. An example, right? The days are getting shorter. It's almost December. The advent of code is a sort of an online thing where in the weeks leading up to Christmas, every day you get a little challenge. It's also writing based. It is, here's a puzzle, you write the program. It's never, here's a program, figure out what it does. So as professionals, we never really practice reading. And then finally, what also very much matters is that even if you want to do more reading, what do we even do, right? We don't have proper theories for reading code. What even happens in your brain if you process code? Well, we don't really know. There's some research, super cool work, where people are putting programmers into fMRI scanners to see what actually happens in their brain, but that's still very early days. So if you want to know what happens in people's brain when they read code, sort of the best thing we can do is look at what happens in people's brain when they read something else that isn't programming. So the next part of the talk will be a brief, short introduction into like the science of your brain for programmers, briefly laying the groundwork for 1 or 2 programming exercises that we're going to do after this talk is over. So what happens in your brain if you process information? The first thing that happens is that information is stored in your short-term memory. And this is a bit like an I/O buffer. It is very small and it can only store information for a very brief period of time. And we've been knowing this for a long time. Even in the 1950s already, it was well known by a researcher called George Miller that your short-term memory is very, very small. It can only hold between 5 and 9 elements. So it's very, very, very tiny. And just to show you how tiny, we will do a little bit of audience participation. I hope you have your pen and paper ready, because we will do a first small exercise. I will show you a sentence. This is a 3-word sentence. So it is a brief, brief sentence. And it is your only job to memorize this sentence. It will be shown briefly, like half a second. So do not blink or you will have missed the first exercise. Let's see who gets it. Here we go. Yeah, so the one video feed I have was smiling. So you figure out like this is a what, right? Is this a sentence? What am I looking at? You do not have time to store this in your your short-term memory. So why, right? You figure out I'm mildly cheating. So what happens is that if information comes into your short-term memory, it collaborates with your working. Your working memory is like the processor in your brain. It doesn't remember information only, it also thinks about the information. And whenever information is stored in your working memory sort of calls your long-term memory. It's like, hey, I have some information here. Do you know this information? And your long-term memory is, oh, here's some related information you might also be interested in. So your long-term memory sends related information to your working memory, making it easier to process the information. With that knowledge, we will do another second experiment. It is the same thing. So I will show you a sentence briefly, a 3-word sentence, but it's a different sentence. So maybe this time you will do better. Here we go. I hope you're ready. So that was easier, right? It was still very hard. Probably no one got it. If you want to try, you can type whatever you have remembered in the chat. But it was easier. And hopefully you realize that your long-term memory was activated. That your brain is like, letters, letters, this is letters. I know letters, right? So something was happening. You were activated in a way that you definitely were not activated in the first language. And then we will do one more, just because I want to show you that it is possible to remember a 3-word sentence in this brief period of time. Like, I'm not giving you an impossible challenge. It's actually relatively easy. So here we'll do a third one. Let's go. Probably you got that, right? The sentence was cat loves cake. And the reason you can remember it, even though it's shown super briefly, is because your brain immediately transforms the shapes into letters, the letters into words, and the words into concepts. So you are not remembering half a circle and a circle with a stripe and a big cross and then a stripe, right? You're immediately thinking of a concept, a cat, love, and cake. And this doesn't take you any energy, even though it's sort of a weird sentence, right? Because what cat loves cake? But you can immediately do it because the information is retrieved from your long-term memory. Immediately it's like, ping, ping, I have some information. Oh, cat loves cake. Got it. No problem. This is really easy. So the basics is we have short-term memory and long-term memory and working memory, and they all play a different role in processing information. And this is also true if we talk about processing source code. So I want to look at 3 different programs. And these 3 programs correspond to different forms of confusion. Program 1. This is a program in a programming language called APL, a programming language. And if I would ask you what this program does, probably the problem lies here in this T thing, right? You know what 2's are and you know what an N is. Probably it's a number, probably it's an integer, but then you look at this T and you're like, your long-term memory is like, I got nothing, buddy. I don't know what it is. It's a T, but what does it do? I don't know. So this is a specific long-term memory issue. Here's another issue, and this is very, very different in nature. This is a program in Python. And if you are a Python developer, then probably for you, this is easy. This is cat loves cake, right? Because it's just a list comprehension with a filter. No big deal. But if you're coming from a Java background or another C-like programming language, where they do not have this idea of a list comprehension, in that case, it's many different elements. It's like customer names, C first name, 4C in customers. There's so many individual elements that it's hard to really figure out what's going on, right? Okay, I see a 4, but it's in a weird place. I expect a 4 in the beginning of a sentence, and there's an if, but it's not indented, and there's no blocks. So your brain might get overloaded if you do not have the right prior knowledge for this. So this is potentially a short-term memory issue. This program is a very, very different form of confusion again. If you look at this program, probably your long-term memory is okay because you know all these things. Let and apps, and you see a return statement and a print and a for loop. So your long-term memory is, okay, I see what's going on. Very different from the T we had in APL. But then your working memory is still like, okay, I know all the individual elements, but like, how do they connect to each other? That's the problem here. And you almost want to go like, okay, let's step through this program. Let's say N is 7, then N2 becomes 3, and then B string becomes a string 1. You have to line by line mentally execute the program if you really want to figure out what is what. So this is a working memory issue. And you see that these things are very, very different from each other. So what I'm seeing with people is that very often they say, oh, reading code is so hard. It's so hard to read unfamiliar code. It will be easier if I just rewrite everything, right? I have also been guilty of this, where someone contributed something to an open source project and I look at it as like, I don't get it. I will re-implement it. This will be easier. Of course, it's never easier, right? It would be easier to just use what is already there. It's just not easy for me. So the good news is, and that's like the rest of the time we have today, is that we will practice getting better at code reading, because you can get better at code reading, right? It isn't like code reading is naturally hard. How can code reading be harder than code writing? Like, that would be weird. It is just that the culture that I talked about earlier in this talk emphasizes writing always, writing only, and doesn't emphasize techniques that can be useful for reading code. We never learned these techniques. We never practiced these techniques. So of course, it's going to be really, really hard. So if you understand in a program what type of confusion is going on, then you can read better. So it is time for the actual code reading exercise. What we're going to do, it is basically the same as we did with the short sentences. I will show you some code, and it is your goal to remember as much of the code as possible. Don't worry if you don't get everything. The goal is not immediately to learn everything. We will do 2 exercises on the code snippet. So you will see the code again, and then we will dive a little bit deeper. But the first exercise, the goal is just to try to remember as much as possible from the code. And I will give all of you 2 minutes to read the code. And then we will see. I hope we can have a chat. Do we have a chat, Jousef, where we can talk about experience? Fantastic. Yeah. So for 2 minutes, I will show the code. You try to remember it as best as possible. Do not make notes in the 2 minutes. Just remember it with your brain. I will then remove the code, and then you will try to write it down, right? So it's not an exercise in copying the code. I will show the code for 2 minutes, and I'll give you another minute to write down everything. And then together, using the chat, we can reflect upon our findings in trying to remember the code. So no cheating, no screenshots, no copying. You're just really doing this exercise for yourself. It's not for course credits. 2 minutes, starting now. Try to remember the code. I will tell you when the time is up and when you can start writing it down. Here we go. Oh, I'm so sorry. This is the one. Yes, here we go. Okay, so the 2 minutes are up. I have removed the codes. Take your pen and paper and try to write down as much as you can. I'm gonna give you about a minute to write down as much as you can remember. Okay, that was a minute to write down. I will now once more show you the code so you can go over your notes and you can look at what you remembered. So I'd like to open the chat for people so they can share sort of what parts did they remember, what parts did they totally miss. I'm really happy to hear some experiences how this was. I don't think I see the chat yet. Jousef. Maybe is there something we need to enable from? Ah, there we go. Yes, now I see it. Perfect. Okay. Someone is saying not so good. So I'm not so much interested in like how many lines you had. I'm specifically interested in which parts did you remember. The login part to check the login data was correct. I didn't get to the game part. I just had 5 lines. Great. Anyone else wants to share which part that they had? So maybe the person that said I had the login part correctly, scattered codes all over the place. Interesting. Could write some part of both the functions, roughly 5, 6 lines, including the def part. I could remember the variable initialization part. Yeah, that makes sense because both it is at the top and it's also sort of rememberable because it's very language independent. Question, answer, username, password. Yes. So actually, I did this exercise myself in preparing today. So I totally forgot about the line splits in the game. But then somewhere I remembered, oh, there's two variables like question and answer. They're sort of reverse engineered. They must come from somewhere. Yes, and Rime is also saying it's very hard to memorize something if I don't understand it entirely. That is one of the things that we're learning here today. So I want to do another exercise. It is again the same exercise, but it's a different piece of code. So we're going to look at a different piece of code. It is smaller. It is less lines of code. So maybe it's easier to remember, maybe it isn't. It will be just the exact same exercise. I will show you this piece of code. This is C. And then looking at the code, 2 minutes, reproducing 1 minute, and then reflecting on what we have learned. Here we go. This is the code. You have 2 minutes starting now. So that were the 2 minutes. I'm going to take the code away and give you about a minute to try to reproduce as much as possible. Okay, so I want to hear experiences again. I will show the code in the slide so you can look what you had. And I'm really curious to read, like, easier than a Python code, harder, what parts did you get, what did you totally miss? Let me know in the chat how this was. Harder, because it was harder to understand. Didn't remember more than 3-4 lines, harder than a Python code. Yeah, that was my expectation, that this was harder, even though it's so much less lines. Yeah. So the general consensus is saying that it is harder. Also because it doesn't have syntax highlighting. I think that's also a very interesting remark Sebastian is making, that also makes it harder. Yeah. Runal is also saying it's harder because I couldn't abstract. That's actually what we're going to do in the next exercise. So you really hit the nail on the head there. You're saying that you cannot really remember what the code is doing as a whole, so you have to remember individual lines, not so much reproduced. Okay, very, very cool. This more or less corresponds with my expectations of what you would think is harder and easier. So a few things to take away from just this exercise and what we've seen so far. What someone already also said in the chat, that it's very hard to remember what you don't understand. And I think if you are in a situation where you work in a project and you're onboarding people and everyone is hiring, right? So everyone is almost constantly onboarding new developers. If you show them something, even if it's in a language that they might be familiar with or a language that they've seen before, if you don't really understand how everything goes together, it's very hard to remember, right? So I definitely made the mistake onboarding juniors earlier in my career where I would show them something like this. Like, look, this is our initialization code. And I would just show it to them briefly, like not with a stopwatch, right? Not like, oh, for 2 minutes, but you just engage with someone in a code and you assume that they can remember it because they've seen it. But if it's so far over your head that you don't understand it, you don't even remember it, right? So then the next week, I'm like, hey, have you looked at this memory allocation code? And it's like, what? Like they don't even remember seeing it, which only makes sense if you really have this experience of how hard it is. And you see that prior knowledge, what most of us have a little bit from Python, really, really helps, but also structure. So some things were remarked already, right? Like it has no syntax highlighting, it's very, very hard. Also, it sort of lacks structure. Whereas in Python, we clearly had these two pieces. So already your brain's like, oh, two chunks, game and login. Already every line can be classified in its role in a specific block. And this is just what, right? Or this is all the code there is. So if you don't understand something, it's spectacularly harder to remember it than if you do understand it. So if you're in a code base with people with different levels of experience with the languages and with the code base and with the domain, they're not seeing the same things, right? They literally have a different view of the world. So that is a takeaway. Another takeaway here, and that's a takeaway I think is really interesting going forward if you want to engage with code more, is that this remembering exercise is also a great diagnostic tool. There exist probably people, I am not one of those people, but there are people that read this C code and they're like, oh, this is easy. I can easily remember it. But for us mere mortals, it's really hard. The reverse is also true. Probably there are people for which the Python code is more confusing because it's something that we're really, really not familiar with. So how well you are able to remember something is a great tool you can use for diagnostics, for self-diagnostics. So suppose you would remember this part, and this is a insertion sort, and I ask you to remember something, and this is what you remember, then that says something about the things. And this is Java, I think. Yes, I think this is Java. The things you know in Java, right? It tells you something about the concepts you have memorized to such an extent that it becomes easy to remember them. Whereas some of the parts will never be easy to remember, right? The concrete values that you have in the code, like 45, 12, and 8, that will never be easy. But remembering specific constructs, if you can remember them with ease, that means you really, really know them very well. So remembering is both something you have to think about in onboarding and also something you can use for diagnostics. So I want to do one more exercise with the same two pieces of code. So we will look at the Python code again. We will look at the C code again, just to give you another exercise that you can do if you're engaging with code that is unfamiliar to you. So the exercise here is that I give you a piece of code, and then the goal is for you to summarize it just in 2 or 3 sentences. Try to explain what's going on. And the nice thing is that this very often forces you to go back to the code. So you get a piece of code, and if I force you to make a summary, you're like, right? Okay, what is the essence here? What are the most important pieces of this code? You're forced to reproduce. So we will do this exercise with the Python code. We will not do a timer. This is a bit more free form. You can just type your summary. Try to keep it in 1 or 2 sentences. Try to type your summary in the chat. So here's the code again. How would you summarize this code in 1 or 2 lines? Okay, I did a summary myself as well, and I'm seeing one. Ask the user for a username and password to access a game, including scores and live. So mainly for that answer, the focus is on the sort of the lower half, right? The username and password, and then this is a game. I think my answer sort of had to reverse. So I was more focusing on the game if you log in. So that's already an interesting difference. One more. You log in and enter a quiz. You get 3 random questions. Log into the game with a valid username and password. You receive 3 questions. It's interesting. So the 3 questions is something that many people pick up on as something that's important. But already you see some deviation also. So you see similarities, but there are also some people focus a bit more on this part, and some people focus a bit more on that part. These are the next one that I'm seeing is two relatively long sentences, then you can cover a bit more, of course. So you see that creating a summary is a good way to really figure out what's going on at a higher level of abstraction. It doesn't necessarily have to be line by line, but it helps you to understand. And the nice thing, though, about these summaries is that they're super good for understanding. If we look at research into natural language learning, then this is something, if you want to practice text comprehension, writing a summary of an essay, writing a summary of a newspaper article or of a book is a technique that we use in natural language learning to practice sort of sifting between the main points and the side points, the things that are not so relevant, right? Like, what is the file name? What is the exact phrasing of the text that we're printing? We abstract away from the details and we go towards the more important. We will try. I know it's hard, but I want you to try, because in such an exercise, this is where it is hard. It's like weightlifting, right? First you look at 50 kilos, you're like, oh no, this is impossible. But then if you practice, it will get easier. It will always be heavy, but it will get easier. So I also would like to see, what can we make of this? If you're asked to write a summary of this, what would you write? One or two sentences. Try to get to the gist of this program. Okay, so I'm slowly seeing some summaries come in. I understand this is maybe harder than the Python code, but still we are getting something. So decide group size and what user should be included in each group. Memory allocation for structured groups containing size information. Creating and dividing space in the memory location as smaller folders based on the incoming data size. Interesting. So I also don't really exactly understand what this code is doing. I just like grab this code from random websites that have codes. But I think a few interesting things to note here in trying to do this summary. Firstly, I think what's interesting to note is that the comment here that's in the middle really plays an important role in understanding, right? So the comment here is very, very different. In the previous code, there wasn't even really a comment, but the comment here does help us because that word allocate, of course, there's a malloc lower on, but this word, oh, allocate, this helps us. Oh, maybe this has something to do with memory. And also, what we're seeing is that probably you're very much also here, less so with the Python code, also relying on syntax, right? So you're seeing, oh, it must be a pointer because there's a star and there's an arrow. It is harder to grab the information just from reading it, just because it's not so verbose. And also, I think what really was for me a blocker is I didn't understand and still don't understand what a gidget is here. What is a gidget? What is a gidget size? So what you also see is that in understanding code, you're not just looking at understanding programming concepts and syntactical constructs. You also have to have some understanding of the domain. And in the Python code, the domain is really easy. We understand what is a user, what is a password, what is a game, what is a question, what is an answer. So in the Python code, there's no domain confusion. It's very clear what the thing is that we're talking about. Whereas here, what is a group exactly? Yeah, a group is a bunch of things. What is a block? What is a gidget? What is the info that we're looking for? So this piece of code, of course, this is like why I chose this. It has a mix of complexities. It doesn't have structure that helps us. It doesn't have syntax highlighting that could help us. But also, most likely, we're also confused here about domain concepts. And this is one of the things, also one of the deeper exercises I have, where we're not going to do today because this is like just a little flavor today. But one of the exercises also that I will go deeper on in my upcoming book is this difference. Like, what is the confusion that you have about the domain? What is the specific confusion you have about programming concepts? And what is the specific confusion you have about syntactic concepts? These are different things, right? Maybe you're really aware of the domain, but you don't know the programming language. That's a different type of confusion. If I'm reading something about questions and answers and file opening in TypeScript, that's really different than if I'm reading something in Python that I know really well, but it is about a domain I have no understanding about. These two are, again, different types of confusions. And if you understand why something is hard, then it already becomes less hard because you at least have a path towards knowing more. So this was just a sort of to give you a taste of what you can do, what types of exercises you can do if you start to say, okay, I want to engage with code in a different way. I don't necessarily only want to write code. I don't necessarily only want to execute code and execute tests. I also want to engage in code in a different way. So one of the things you can do if you're like, this was fun, I want to know more about the cognitive architecture of the brain and how that matters for programming, I want to do more exercises to deepen my understanding, you could read my book. It's called The Programmer's Brain. And now I should say, read my first book, because I'm actually working on the second book for O'Reilly called Code Reading in Practice, that will dive even deeper into code reading exercises. So it would be very cool if you would try to check out my book. What you can also do, if you're interested in doing more of these exercises in a company setting, is start something that we call code reading clubs. So we come together every month, and then we take a piece of code, like the ones we just looked at, not too big, and then we engage with the code, with these exercises, with a group of people. So there's this open club every first Tuesday of the month that you can join online. But you can also, if you think, oh, this was fun, I want to do this with my coworkers, do this within your company as a great way also of team building and onboarding people. And I have some links here to both of these things. So as I said, I'm on Twitter. My Twitter handle is @Felienne. I'm on the web as well. My website is felienne.com. And if you want to know more about the book, you can simply go to felienne.com/book, and they can order their book there. And if you want to know more about code reading clubs, you can go to felienne.com/club, and all the information, which is free and open source, by the way, the code reading club stuff, it is all there.
Amazing, Felienne. Thank you so much for the session. I've actually just pasted the link in the chat. So if people want to access your links, also a 35% discount that Manning gave us for your book. So if you want to check out Felienne's book, I have your book, by the way. It's really nice to read. Definitely worth checking out, guys. Do you have any questions to Felienne before we wrap it up? raise your hand or just unmute yourself or ask in the chat. Don't forget to connect with Felienne on LinkedIn and also Twitter. Any questions, guys? No? Okay, cool. I mean, Felienne, you have your own space in the community. I've already invited you. Oh, okay. What presentation?
Oh, yes. Yeah, so the software was just Keynote, but I guess you want to know like how I made the little doodles. So I draw them on my iPad and I use an app called GoodNotes. And then that just creates image files that I drop into Keynote. So the presentation itself isn't very advanced, but I make all the doodles with GoodNotes, like manually, with not with digital software, but with a pen on the iPad. So it's actually like hand drawn, only mildly digital. Thanks, Madhavan.
Really cool. Thanks for being so engaged, guys, and also for the engaging session, Felienne. And if people have any questions, sure. If people have any questions, they can reach out to you or either via LinkedIn or Twitter, or we have a special space, as I've already said, to ask some questions. Cool. Felienne, thank you so much. Cool. And hopefully see you soon in the second session in the future.
Yes, enjoy the rest of the week.
Bye-bye.